What is latent heat of condensation? Imagine water vapor floating high in the sky, ready to change into liquid droplets from clouds. But what really happens when vapor turns back into liquid? That's where the concept of latent heat of condensation comes into play. Latent heat of condensation is the energy released when water vapor changes into liquid water without a change in temperature. When water vapor cools down and condenses, the molecules slow down and bond together, forming droplets. During this process, the molecules lose energy, and that lost energy is given off as heat. This heat is called latent because it is hidden inside the phase chain and doesn't cause the temperature to drop or rise. In the water cycle, this process is very important. When vapor condenses into clouds, it releases a lot of heat into the surrounding air. This released heat warms the air nearby, which can cause it to rise and create upward currents. These currents help drive weather patterns and cloud formation. The amount of energy released during condensation is quite large. For every kilogram of water vapor that turns into liquid, about 2,000 to 157 kilojoules of heat are released. To put that in perspective, that's more than 5 times the heat needed to boil a liter of water from 0 to 100 degrees Celsius. This large releases of energy explains why condensation and steam are so effective at transferring heat in the atmosphere. This energy releases during condensation also influences weather events like thunderstorms and hurricanes. When water vapor condenses in storm clouds, the heat released helps fuel the storm's growth by warming the surrounding air. This process creates a cycle where warm, moist air rises, cools, condenses, and releases heat, which then encourages more rising air and cloud development. In summary, the latent heat of condensation is the heat energy given off when water vapor turns into liquid water. It happens without changing the temperature but releases a significant amount of energy that warms the air. This process plays a key role in the water cycle, weather formation, and climate regulation. Understanding this helps us see how water vapor influences the atmosphere and why condensation is a warming process in the sky.